Today your notes are on 8-1, the Pythagorean theorem, and your notes are brought to you by Disney. You're going to be taking some short notes at the top of your notes, and the remainder of your page, 3/4 of your page, should be split as follows. You'll be doing 5 examples. 3 of them are relatively short, and 2 of them are kind of large. I wanted to tell you that in your notes, the examples that I'll be doing, I'll be giving you the decimal approximation. In order to get credit for your notes, you're going to need to write the simplified radical form, which is not in this video. Let me give you an example. Suppose you have the square root of 24. The square root of 24 is approximately 4.89. And that's an irrational number, it just keeps on going. That's the decimal approximation that I'm going to be giving you. But your simplified radical form, what I'll be looking for you to finish in your notes, is that the square root of 24 is actually the square root of 2 times 2, that's 4, times 2 times 3, 4 times 6. I pull out my perfect square. My answer is 2 square root 6. Make sure you keep in mind that while I'm giving you this in your notes, I'm going to be looking for this in your notes that you create. Go ahead and write vocabulary at the top of your notes, and what we're going to do is kind of take a closer look at right triangles. The first thing I wanted to show you is the different orientations of a right triangle. I can flip it on its side, I can rotate it completely around, I can turn it this way, I can make it bigger, smaller. There are not a lot of things I can do with right triangles to make it interesting. I could put them back to back, maybe. I want you to think about what that means depending on the orientation of the triangle. So you've already written vocabulary down. But now that we've moved our triangles around, let's see if you can identify the hypotenuse and the 2 legs. So in the right triangle, the hypotenuse is right across from the right angle. So for us, this segment is the hypotenuse. And I always like to show that it's right across from the right angle. The 2 other sides, the sides that are connecting to the right angle, the 2 sides that are perpendicular, those make up the legs. Now for this triangle that I've rotated over onto its side, now I'm going to have to think again, what is my definition of a hypotenuse? It's the longest side, the side that is across from the right angle. That means this is my hypotenuse. And then the 2 remaining sides, the sides that are perpendicular to each other, this side and this side, those are my legs. That's the basic information that you're going to need to use the Pythagorean theorem. Okay, we're going to start with a simple example to begin with. The first thing I'd like you to do is write under example 1 the Pythagorean theorem, which, as you remember, is a squared plus b squared equals c squared. Now, more importantly, you need to remember that a represents the length of the leg, b the length of the other leg, and c the length of the hypotenuse. So for this basic example, I'm going to go ahead and give you some measurements. I'm going to tell you that this side is 13, this side is unknown, and this side is 5. Now I know I have a right triangle given 3 different measurements, 1 unknown. I'm going to use the Pythagorean theorem, but before I can plug the values into the Pythagorean theorem, I need to know which is which. I see that across from the right angle, this would be my hypotenuse. That means that the other 2 sides would be my legs. Now given that, I should be able to plug them into the formula. So I'll start with my hypotenuse. My hypotenuse squared is c, or x squared. And my 2 squared values are my 2 legs, 13 and 5. And those 2 values are squared and added together. 13 squared is 169. 5 squared is 25. I start by finding my squares. The sum of 169 and 25 is 194. They're squaring, so I square root. Now using my calculator, the decimal approximation of 194 being square rooted is about 13.94. That means that the hypotenuse is a little bit longer than this leg. It's 13.94, almost 14. In this next example, I'm giving you the same amount of information, but in a different way. So the first thing you'll need to do is draw in your right triangle. This time I've named the points. This is triangle ABC, and I have some given information which you should copy. It says here that AB is 6 and that AC is 20. That means that my unknown side is BC. From here, I'll start with my Pythagorean theorem. A squared plus B squared equals C squared. Now I know my values are there, but the first thing I always should figure out is where are my legs and where's my hypotenuse. Across from the right angle is my hypotenuse. That means that AC is my hypotenuse, or 20. So I'll go ahead and input that value. I'll be squaring it. My two legs are perpendicular. That's a leg, and that's a leg. That means that 6 squared plus x squared should equal 20 squared. Now, an important thing to note at this time, in case you are wondering this, I could have put my 6 squared here and my x squared over here. The order doesn't matter because both values are being squared, and since they're being added together, because of the commutative property, it doesn't matter which one comes first, so don't worry where you put it. Okay, from there, let's do some calculations. I'll square what I know. I can square 6 and I can square 20. That's 36 plus x squared equals 400. Now, unlike my previous problem, where I automatically knew what x squared was, here, the x squared is not alone. This 36 is here. In order to eliminate it, I'm going to subtract 36 from both sides, which gives me x squared equaling 364. They're squaring, so I square root. In my calculator, I can approximate that the square root of 364 is about 19 and 7/100ths.